Thanks very much. Well, here we are, .NET Conf, second day. Thanks to everyone who's been watching so far. I'm pretty excited to talk to you about native AOT with ASP.NET Core. It's one of the things that we worked on kind of for the first half of the release during this year. And then we may have been working on something that we announced yesterday for the second half of the year. But I'm really looking forward to talking to you about native AOT today. So tiny fast ASP.NET Core APIs with native AOT. What is that all about exactly? So why native AOT? What is native AOT all about? Well, it's basically these three things. You want to get smaller apps, you want to get faster startup, and you want to use less memory. Why would you want to do those things? Well, for ASP.NET Core, at least for this release, the primary focus was around enabling more cloud-native type of scenarios. We heard from customers who were deploying ASP.NET Core APIs, maybe gRPC APIs or minimal APIs, HTTP APIs, and they were deploying them into containers, and they wanted to understand some of the behaviors that they were seeing. Like, why does it take this amount of time to start up? Why is it using the amount of memory that it's using? And why is it the size that it might be? And so, especially when they started comparing to other stacks, which we can't avoid, we exist in an ecosystem, and people are always going to compare ASP.NET Core to other potential solutions, and we obviously welcome that. We started going, okay, this is obviously something that we probably need to look at here. What is it that we can do to try and improve each of these three things? How can we make ASP.NET APIs smaller, start up more quickly, and use less memory? So let's go to code, because I do have slides. We'll go back to the slides a few times, but I like to explain a lot of these things with code. I'm just going to create an empty ASP.NET Core application here. We'll call it, where are we? We're at .NET Conf, aren't we? So let's call it .NET Conf 23. And as I said, we're just going to start out with empty. I'm going to untick HTTPS. I don't need that for this scenario. So I'm just going to start out with the most simple ASP.NET Core application I possibly can. Okay, so let's open up our program.cs here. And what do we see? Well, we see our familiar web application, create builder. We don't have any services because this is just doing hello world. And then we go ahead and run the application. All right, well, I'm going to go over to the command line now, and I'm going to have a look at what happens when we interact with this application that I just created from the command line with regards to publishing. So I called it .NET Conf. If I have a look inside here, I've got my .NET Conf project. So here we are. And I'm going to go ahead and publish that. So remember, publishing an application using the publish command is supposed to set up the application ready for deployment to some type of production location. You can see here I've got a message that says it produced a couple of a DLL over here in during the build phase, and then it published the output of the application to the publish location. So if I go ahead and look at that right now, I'm getting nice completion over here. Oh, except I wrote it wrong. That's actually not where I want to go for this one. So I want to go over to bin, doing release by default for publishing now, net 8, and we'll go to the publish output. Okay, so I can see here what files I got. I've got my a DLL, which is my application, which is actually really, really small. It's only 5 kilobytes. And so, well, this is a good reminder that by default, when you publish an application, we do what is called a framework dependent deployment, or FDD. You might see that acronym show up in documents. And so this application requires a runtime to land on. You can't just take this application and run it on any machine. It is framework dependent. Now, it does have an executable here. So that is what we call effectively an app host, so you can run that executable and your application will run. But all this is really doing is locating the DLL next to it of the same name, and then it still needs a framework to land on. And so that's one of the reasons why this is so small. There's no ASP.NET Core in this DLL. There's no .NET Core in this, or .NET in this DLL. It's really just your application pieces, which is so small. What we find, though, is that in a lot of scenarios, people are wanting to deploy the whole application, not just their code and their dependencies, but they also want to deploy something that's standalone or self-contained. And we have a different deployment mode for that. So if I go back to my project, I'm going to go into my project file, and I'm going to add a property called publish self-contained. And I'm going to say true. And so now when I go back and I run publish again, we're going to see a slightly different behavior this time. So that was very quick. I'm going to pass the self-contained flag and type it correctly. There we go. And so, oh, what have we got here? Unable to resolve for net A package sources enable. Oh, I must have a feed that I don't want to be using on this machine. So let's have a look at our feeds here. That's fine, that's fine. I'm just going to check my global package sources here. I might have a leftover package source from setting up a few things. All looks fine over here. That looks correct, that looks correct. Let me go and quickly have a look in the location that I'm executing in here. Let's have a look. No, I'm not seeing anything. That's a strange issue for me to be seeing. Okay, let's make sure. Package was enabled, were not considered. Why were they not considered? Unable to resolve for .NET package sources. Let's just try that again. I'm going to try a restore and I'm going to force it just here. Okay, that all looks fine. I'm going to try a build here. That all looks fine. Let's do a publish. We'll do a self-contained. Still giving me that error. That is unusual. Okay, let me go back and we'll do a clear here just to make sure that I don't have anything left around that I want to. Let's have a look. What do I want to do? I want to we're going to go ahead and you know what? I'll just do this manually. I'm going to go in here. I'm just going to clear my NuGet cache. I think I may have something latent left over. Unfortunately, I did have to change machines a little bit late while preparing for this demo. So let's just see if we can't unblock myself here. Okay, while that's going on, just want to make sure I'm really not seeing a NuGet config here. Let's have a look. And if we can't get this fixed in the next second, I will just hop back to the slides and we'll talk through what we're going to look at next. All right, what are we seeing over here now? All right, that's complete. Let's try that one more time then. We'll go back into our app that we created, which was .NET Conf. We'll have a look inside here. All right, let's do a clean here just to make sure we're in a good state. Okay, and then we'll do a publish. Let's make sure our regular publish works. Okay, that seems fine. Let's do our self-contained publish. Okay, no, it's really not going to help me there. Okay, let's come back to the slides. All right, so why does native AOT work? Or how does it work, I should say? When we publish native AOT, which I'll get back and try in a little bit moment, and hopefully we won't run into the same issue. C# that you write in your application is compiled into IL. That happens thanks to the C# compiler, and it happens during the build phase. And then when you go to publish your application, the IL that was produced is compiled to platform code. And as I said, that only happens during publish. So platform code meaning it targets the platform that you're going to run your application on, x64 for Windows or Linux, ARM, if that's what it is that you're targeting. The published app in this scenario, though, has no JIT. Okay? So there's no JIT in the runtime that's embedded in your application when you publish as native AOT. It still contains a runtime. So it's important to acknowledge that these are still managed applications. There's still memory management going on. There's still a GC going on. But it is a standalone native executable. There will be no JIT that happens when the application starts up, which is one of the reasons why the startup can be so much quicker. It'll also be single file. And so that's what I was trying to demonstrate there. And it will be trimmed to reduce the app size. And trimming is something that's been available in .NET for a few releases now. I heard David talk about it yesterday, and we mentioned it briefly in the keynote. And there are some compatibility considerations to take in when using trimming, because effectively what we're doing is trying to find all unused code in the application and then remove it in order to reduce the size of the application. It's particularly important in native AOT because things that we can express in IL and that then get turned into platform-dependent code by the JIT, typically, cannot be expressed when the JIT is removed. And you have to fully express them in the native code up front. And that's what can lead to native AOT compiled applications actually being larger than their non-native AOT counterparts. And so that's why we trim them so aggressively as part of doing so. And then as I mentioned, they're also operating system and architecture specific. So when you create a native AOT application, you end up publishing for a specific target. By default, when we did that initial publish, which was a framework-dependent publish, that was a portable application. I could take that DLL that we saw, which was my app DLL, it was about 5 kilobytes, and I can run that on anywhere that .NET is installed, assuming I have the right runtime, the right version of the runtime available, or runtimes, as it might be in the case of an ASP.NET Core application. You need the ASP.NET Core runtime, and then you need the .NET runtime underneath it. And you would run that by typing .NET space your DLL name. In the case of architecture specific, that's not true. Like you end up with an executable. If it's a Linux exe, it'll just be the name of your application. If it's a Windows exe, it'll be the name of your app.exe. And then that is what you ship around as part of your deployable asset. Or you might bundle that into a container, for example, and run it in a container. So what is the impact of having no JIT? So I said there's no JIT in a native AOT application. Well, you lose some capabilities that traditionally you may associate with .NET applications, but you may not consciously associate them with the JIT aspect of .NET. So you don't get any runtime code generation because all that code generation is happening upfront as part of publishing your application. So there's no platform optimizations going on at runtime after you've deployed. So you can opt into those as part of your native AOT compile during publish. That is, choosing processor instructions to target so that certain intrinsics run certain ways. But by default, what you'll get is a fairly compatible application. You also get no dynamic PGO. We've talked a lot about dynamic PGO this conference, huge addition to .NET 8, which is on by default for applications. But because it effectively relies on this concept of tiered compilation in the JIT, by watching what methods are being called and then identifying opportunities to recompile them while the app is running to make them faster. That's not a thing you can do if there's no compilation happening in your app at runtime. And so you don't get that benefit. Now, there is static PGO in the native AOT world. There is a profile in there. So you do get the benefit of the compiler being able to see all of the application during the compile phase. So it's just a trade-off. It's just a different view of the world going on there. There's no assembly.load file, so you can't scan for assemblies and then load them into your application, which is common in like plugin models. Why? Because, well, those assemblies would be IL, and then they would need to be JITted into machine code, and there's no JIT, so you can't do that. There's no expression compilation. So if you're building up dynamic expressions or using a library that does that, and then it relies on being able to compile that expression for performance, that compilation just will no op. It won't actually perform. What will happen in a native AOT application when an expression is executed is actually gets interpreted. There is an expression interpreter in the native AOT runtime, so it will work, but it certainly won't be as fast as it may have been if it was compiled, like it would be with the JIT. And then lastly, reflection.emit or ref.emit, which is a very popular way to do high-performance code generation at runtime. Again, no JIT, so we can't emit IL and have it compile because there's nothing to do so. All right, what about the impact of trimming? So I talked about there being no JIT and what that means for your app, but what about the fact that there's no trimming going on? Well, unreferenced code, the code that has no callers, is just removed. And it's unreferenced code from the point of view of what the compile toolchain can observe. It needs to statically analyze. It doesn't run your app. It simply analyzes your app statically at publish time to determine what it thinks is not being called by your application. And then it removes code that is not being called. So that can lead to problems for certain types of patterns. There is no assembly or type scanning as a result because you might be trimming things away that aren't used. And then you go to scan for them, or whether they're assemblies or types, using reflection APIs, and then they're not there because they got trimmed away. The opposite thing can also happen, which is if you're trying to make the app as small as possible, there are certain code patterns that can result in code not being trimmed away. And that's because the static analysis can't determine which branch is going to be used, and so it has to keep both. It can see that there are call sites to both. It can see that those call sites are rooted from the start of your application, but it doesn't know which one you're going to use at runtime, and so it keeps both. And here's a very rudimentary example. Perhaps you have some config feature switch, which you pull out a configuration at runtime, and then if it's one value, you do one branch, and if it's another value, you do another branch. Well, that API design in native AOT will typically result in both branches being kept, even if in a certain environment, only one of them will ever get used. And this type of thing was actually something that we had to deal with quite a lot when making ASP.NET Core itself native AOT compatible. We did have to do some API redesign in order to address some of these things. Let me show you some examples of that. If I go back to the project here, and I'm going to change this to publish AOT, and we'll hope that publish AOT works and I don't hit the same problem I just hit before regarding my NuGet feeds. This keyboard is different to my other computer that I just switched from. Okay, so we've got this create builder API up here, which is the root of starting your ASP.NET application. The create builder offers lots and lots of defaults. You get default configuration providers, you get default logging, you get Kestrel as your default, you get certain middleware added, developer exception page in development, routing is added for you by default, so on and so forth. But some of those things can result in the app being a little larger than we would have liked it, given the target cohort that I mentioned earlier. We're really looking at cloud native sort of API-focused apps for this release with regards to native AOT. So in order to help there, we created this new Slim Builder API. And the Slim Builder API, as you can see, is available on the same type web application. You can call it in the same way. You just get less of those defaults. So for example, there's no automatic light up on IIS here. So if you're deploying to Windows, native AOT is not supported with the IIS ASP.NET Core module. You can't compile native AOT and then run in IIS the same way you can today with ASP.NET Core, and so that's removed from here. Similarly, the routing system is still there, but we removed things like the regex constraint-based route because regex is actually quite a large code base, and the way that the routing constraint stuff was built ends up pulling in a lot of code there that you would then have to keep in the application even if you never use a regex-based route constraint. And there is a number of examples like that throughout the builder where we chose, we made some decisions that trade off between what do we want to work by default without you having to call more methods or perhaps support you setting a configuration value that turns on something in certain environments versus how much size you want to pay for in your application when using this API if you're publishing to native AOT. So create Slim Builder. This application I know for a fact will absolutely work if I publish it as native AOT because the Slim Builder still supports routing. It adds it by default. The map get method down here is relying on endpoint routing. And we've done the work in ASP.NET Core to make these map calls support native AOT by way of a new source generator that is enabled by default for you whenever in your project you set publish AOT to true, which is the request delegate generator. And that's going to generate a bunch of code in your application scribbled away like source generators do, so that these methods here, rather than going through their normal code path, which is what they do in ASP.NET Core, obviously, and do a bunch of runtime code generation to generate a very efficient route handler method for you, we instead do that at compile time. And it's effectively the same code. If you were going to go and look at the code, you would see that it basically looks very similar to what would have been generated at runtime, with just a few little caveats, and those caveats are documented. But what it means is that this can now be native AOT compiled, and the trimmer can understand what it needs to keep and what it can safely throw away, which is fantastic. Now, if you want to go even smaller, so I know like the numbers here, if I was to use the builder and native AOT, this app would be about 15 megabytes on Windows. If I use the Slim Builder and then I do it, it's about 10 megabytes on Windows, which is pretty good because a self-contained app that's not native AOT compiled is more like 90 megabytes. So that's quite a huge change, 90 to 10. But if I want to go even smaller, there are some things you can do. So we have a new method here as well, which is create empty builder. And it doesn't even take args because args would imply that we add the argument-based configuration provider for you, which we don't because it's an empty builder. So instead it takes a new instance of an options type. And so the empty builder is pretty much as empty as you can get. It has no server. So if I try and run this application, I would get an error because there's literally no web server that's added by default. But I could go back and add the server. I could say builder.webhost. Use Kestrel, and now I've got a web server added back in here. And if I wanted to craft Kestrel even more, I could say use Kestrel core, and then I wouldn't even get the Kestrel defaults. It would be my responsibility to bring back in exactly what it is in Kestrel I want supported. Do I want HTTP2 and HTTP3 support? Do I want HTTPS support to be on by default? You would get to control all of that by calling these lower level methods. And all of these things do add up. They do add up to quite a difference. Right now, there's actually no routing added in this application. Even though there's a map get call down here, there's actually no routing services. So if I was to try and run this and hit this endpoint, I would get an exception because I didn't add the routing services because this is the empty builder. So I could go ahead and add those by services.add routing. And then I would end up with the routing services as well. And you may have noticed in IntelliSense there's a routing core, similar pattern here where you can go drop down to the lower level method. Sometimes there's a slim method, and most of the time you'll find this core method. And that's just less defaults. It adds the absolute core required for a feature to work, but you don't get any of those nice defaults usually. And if I do that, if I was to do all of this, not even use routing, perhaps I could even comment this out and just use a classic middleware for my hello world instead, like an app.use, and pass a middleware delegate. You can get this down to like 5.5 megabytes on Windows, but you don't get any logging, you don't get any configuration providers, you can't read from environment variables by default, you can't read from your app settings.json by default. We think those are reasonable defaults to have, even when native AOT compiling and running in a container and the type of workloads we're talking about. So we left all of those things on when calling create slim builder. But now you kind of understand the difference between what create builder does, which all the defaults that you've enjoyed in ASP.NET Core for pretty much all versions. The new Slim Builder, which just turns off some of those defaults because we don't really think they make sense most of the time when doing this type of application development. And then there's the empty builders. Like to use Hanselman's example there, I want to drive a stick. I'm going to do it all myself. Just give me the controls and I'm going to manage everything without you getting in the way. And depending on what you call and how you do that, you will end up with different size applications. So I will tempt the demo gods and I'll see if I can publish this application. Now that I've marked it as native AOT, no, it's going to give me a wall of error. So I'm not going to do that. I obviously have a NuGet problem on here at the moment, but that's okay. All right. What other considerations are there when targeting native AOT? Well, there's no C++, CLI, or COM. As I said before, it will be a single file application. You do have extra build time prerequisites. So you can't just build using .NET CLI that you use today. You will need that plus something extra. You need a native compilation toolchain. On Windows, that's the Visual Studio C++ desktop development workload. On Linux, it's tools like Clang. And then on Mac OS, you need the Xcode command line tools installed. And then we have this all obviously covered in the docs to give you the absolute install lines and things that you need in order to do so. You cannot publish cross-platform. So if I'm on Windows and I want to publish native AOT for Linux, I can't do that as simply as I was trying to show you here. You have to be on the same platform that you're publishing for in this world. And so tools like Docker can be very useful for that. If you want to do Docker build, I recommend you go and watch the container talk coming up that's I think is later today. Docker build is something that you could use for that. On Windows, you could also use WSL. Have .NET installed in WSL and do your building inside there. What other publish options are available? We talked about framework-dependent native AOT, but there's a whole bunch in the middle as well. If native AOT seems a little bit too restrictive for you right now, bear in mind you can still do self-contained deployments to get a standalone application that doesn't need a framework. You can still enable trimming to get it trimmed down to only the parts that it needs, and you'll have to deal with the trimming compatibility. And you can enable ready to run, which will pre-compile your application so that it doesn't need to JIT at startup, but then you still get the benefits of JIT because ready to run doesn't remove the JIT from the application. So it can still do tiered compilation and things like dynamic PGO. And then obviously single file is something that you can turn on without native AOT as well. But native AOT is definitely sort of the peak of the optimizations, and as a result, there's some compatibility things that you need to deal with. There's lots of other publish options that you can use here as well to tweak a few of these different modes. With AOT, you can optimize for size versus speed. The default is to optimize for size, which makes it slower, but you can also optimize for speed, which makes it a little bit bigger, but does run faster. Then there's things like invariant globalization, support for event source, server garbage collection, and the new garbage collection adaptation mode, or DATUS, that I know David Fowler talked about yesterday in his performance talk, which is optimized and attempts to use much less memory while using server GC and adapting that memory based on what the application actually requires. So ASP.NET Core Native AOT, what does it support? Kestrel, middleware, minimal APIs, as we talked about, gRPC, JOT authentication, authorization. In .NET 8, there isn't support for MVC or Web API, Razor or Blazor or Signaler, but those are things that we're considering for future releases. For data access, the Postgres SQL ADO.NET driver and SQLite are both supported for native AOT. Dapper.aot was released just yesterday, so if you're using Dapper, there's an AOT version of that. And there's also a small library that I've written that you can try looking at. And Entity Framework Core is something I know the team is interested to look at in .NET 9. I'll just skip those ones. I want to get back right back to these related sessions. So to learn more about this, there's a great talk coming up, I'm sure, from Chet and Richard about .NET containers, which is later today. And then tomorrow morning, very early, there's a talk about C# interceptors, which includes some discussion of AOT in there as well. So some resources here pointing you to docs and whatnot, but otherwise, thanks for this time. I'm sorry that my NuGet gave me a little bit of problems here, but I hope that you learned something about native AOT. I encourage you to go and read these docs. And if you have any questions, reach out to me on Twitter.